Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2021 spring, 10B problem 14, but you can also find it from the 12B problem 8, and it deals with geometry. I hope you guys enjoyed this video and let's get started. The problem states 3 equally spaced parallel lines intersect a circle, creating 3 chords of length 38, 38, and 34. What is the distance between 2 adjacent parallel lines? So it tells us that 3 equally spaced lines intersect a circle, so I'm going to draw a circle here, and then it creates 3 chords. So a chord is basically just a straight line across the circle. And so for a chord, the length of a chord depends on how far it is from the center. So if this is the center of the circle, the chord that passes through the center would be the longest, obviously, because that's the diameter. And then as chords move away from the center, they get shorter. Obviously, my circle is not drawn to scale, so it might look a little different, but we know that we have 2 chords of length 38. And so that means that they must be equal distance from the center. And then we have a chord with length 34, so obviously that's farther from the center of the circle. So it'll be right here. And keep in mind that the distance between these lines are the same. And so I'm going to let the center of the circle be O. And then the distance from the center of the circle to the chord with length 38, I'm going to let that be D. So that means that that segment's D, this segment is also D. And then this segment would be 2D. And once again, my drawing is not drawn to scale, but we know that the distance between these 3 chords are the same. And so if this whole distance is 2D, then that means that this distance is 2D as well. I'm going to let the radius of the circle be R, and I'm going to draw the radii to the points where the lines intersect the circle. And so that way we can create 2 right triangles. So like that. And then I'm going to label the points. I'm going to let this be L and this be R. The center is O. And I'm just going to quickly label some points. A, B, and then the radius of the circle is R. So now that we have 2 right triangles, we have triangle OBL and triangle OAR. So these are 2 right triangles with their hypotenuse being R. And then it tells us that the chords have length 38, 38, and 34. So that means that BL would have a length of 17, because that is 34 divided by 2. And then line AR would have a length of 38 divided by 2, which is 19. So looking at these 2 right triangles, we're going to start off with triangle OBL. So it has a base of 17, a height of 3D, because it is 2D plus D, and then a hypotenuse of R. And then looking at triangle OAR, we have base of 19, height of D, and then also radius, or also hypotenuse of R. So then we can use the Pythagorean theorem to create a system of equations. So we have 19 squared plus D squared is equal to R squared, and then 17 squared plus 3D squared is R squared. Now we can just solve for the system of equations. We can solve for D, and that'll be the answer. That'll be the distance between the two adjacent parallel lines. I'm going to subtract these two equations. Okay, so I misspoke earlier, but we solved for D to get D equals to 3. But then keep in mind that D is just this segment right here. It's half of the distance between the two parallel lines. So we must double it to get the full length. So we must multiply by 2, which gives us 6. So the answer is B.